But I'm going to talk tonight about citizen science, what is it, and how we do it at Smithsonian Environmental Research Center, which in my experience is different from the way it's done anywhere else in the world. So I'm going to share my screen. It is a slide presentation after all. All right, so subject, citizen science, archaeology at the Smithsonian. I love this slide. Benjamin Franklin's kind of a patron saint of citizen science, but he was fairly typical of the people who did science prior to, say, the mid-19th century. Most early scientists, let's say from the 1660s through about 1850, 1860, at least in the Western world, were older white men, and usually fairly wealthy, or at least they had a good living, they could support themselves. They didn't work for institutions. Around the middle of the 19th century, that's when we get the development of what we would call today professional scientists, people who made their living doing science, supported by an institution, initially mostly by universities, eventually by other sources, government agencies and corporations. But Benjamin Franklin, he's kind of an iconic figure in citizen science. Here he is, playing around with electricity. Actually, he wasn't the one, flying the kite. His assistant was. He was in no danger of being electrocuted. So, what is citizen science? I've given this a lot of thought over the years, and I was introduced to the concept only about 10 years ago when I was invited by Dr. Tuck Hines at the Smithsonian Environmental Research Center to start a citizen science program in archaeology. I had no idea what it was. But my initial sense of the term is that it really is just another way of saying volunteers who work in science. And it takes a lot of forms, and one of the earliest manifestations of citizen science was the annual bird count, where folks around Christmas, it's not just Christmas, it's a week around winter holidays, they go out in their backyards and whatever, and they count birds, what species and how many within each species. And they report that to a central data bank. And this has been going on for over 100 years. And so scientists have all this data provided by citizen scientists. So that's one form it takes. Another form, this is one I don't really know much about because I've never been much of an astronomer, weak eyes. But through photography of space, mostly through the Hubble telescope, I think, we've got all these images of outer space, and volunteers help analyze these images, classifying different kinds of galaxies, for instance. So you have all these people out there looking at, I don't know how many millions of photographs, and they collect data on them and they report them to a central database. This is done through a website called Zooniverse, Zooniverse, and you could find this pretty easy on the web if you like. I think for those who might be interested in doing science and participating in science, and getting involved, but maybe aren't up to doing field work, or maybe don't want to travel, you could do it from your own home, your own computer. But like the bird count, this kind of work really involves people volunteering to kind of collect data, and that data is then analyzed by professional scientists. And finally, I mean, there are other forms, but my three examples, classic archaeology, get a bunch of folks out there volunteering, shoveling, screening, washing artifacts, labeling artifacts. These are images are from a program I helped start quite a few years ago in Anne Arundel County, Maryland, still going. And they've been very successful at recruiting people to provide volunteer labor. So that's, and these opportunities are a little harder to find, and generally they're not online type projects. They're in the field, in the lab, but they're out there. And if you're interested, you know, and you can't find anything, by all means, contact me and I'd certainly help. But I want to talk about citizen science at SERC, SERC being the Smithsonian Environmental Research Center, and specifically the Smithsonian Environmental Archaeology Laboratory, also abbreviated as SEAL. So we are, in fact, the SEAL team. Now, the SEAL team, what we do at Smithsonian, this facility is in Anne Arundel County, about 20 minutes south of Annapolis. What we do is explore long-term environmental effects of human behavior on the Chesapeake Bay. And as archaeologists, we focus on variability, how different households do things differently. All of the work is done by our citizen scientists, more or less under my guidance, God help them. And we do really science. This isn't stuff that's made up. It's not make work. It's not for children necessarily. It's actual scientific work that a number of our folks, including a few that are in on this call, have reported on at regional, national, and international professional archaeology conferences. And what we're trying to do, we're trying to, there are 20 other labs at SERC, forest ecology, fish ecology, all sorts of different labs doing environmental work. And they're all working towards an understanding of how the coastal ecosystems have been transformed over the last 3,000 years. And so as archaeologists, we're engaged in that process as well. There's nothing magical about 3,000 years. It's just that this North America, we've got good archaeological information, good data that indicates humans have occupied the Western Hemisphere, and specifically North America, for at least the past 12,000 years. And work that's been done recently suggests we can push that back even further, maybe 14, 15,000 years. However, we're focused on coastal ecosystems, and specifically the Chesapeake Bay. Well, the Chesapeake Bay only started forming as glaciers started retreating 11, 12,000 years ago. And it reached its modern configuration. It matured, if you will, only about 3,000 years ago. So that's what our focus is on, the bay. Prior to that, I don't know how well you can see my cursor, but you might see this dark blue line that runs down the length of the Chesapeake Bay. That's the Susquehanna River. It's an inundated part of the Susquehanna River. That is, as glaciers melt, sea level rose and inundated what was really just a river system. That's why the bay looks like a river system, a typical dendritic river system with smaller tributaries coming into it and it getting larger as it gets out to its mouth. So it's just a submerged river. But about 3,000 years ago, it reached its current configuration, and populations of oysters, pelagic fishes, plants, all started maturing to the point that we see today. The modern bay ecosystem dates back about 3,000 years. And during those 3,000 years, humans have occupied the region, exploiting those resources. So here's some images from SERC, and they look like your typical archaeology volunteers on an archaeological site. You know, folks are doing the usual shtick of, you know, excavating and screening for artifacts. I mean, we need to collect data, and that's how we do it. So that's certainly a component of what we do. What we do differently at SEAL, and I'm going to give you 4 examples of this out of quite a few possibilities. First of all, we have lots of folks who, you know, they love to dig, they love to wash artifacts, you know, whatever. And for a lot of folks, that's all they want to do. You know, they're not interested in doing any kind of statistical analysis, much less report writing or presenting material at conferences. And that's okay. I mean, that's part of citizen science. That's just fine. In fact, all of us do that. I mean, that's a component of what we all do. We all do some digging, we all do some washing, we all do some label. But over the last 9 years now, since 2012, we've had a subset within the larger group, and it varies in terms of membership and number, but we've had a number of folks who have taken on actual science projects. And I'll talk in a moment about what I really mean by that. And it ranges in age. I mean, it's everybody. We've had a 16-year-old run one project, assisted by a couple of retirees. We've got George Reising, you'll see in a few moments. He's a lot older than I am. And he's given several presentations at conferences and runs a number of projects at the lab. So I think that's really important, and especially for those of you who have kids and grandchildren who you think, well, you know, they need some help. You're not sure they're going to make it in life. You know, they're not sure the kind of energy maybe you'd hope, or the inquisitiveness. Working with us is a pretty good deal. We've had several high school students working with us over the years, and all of them have been able to go to the college of their choice, partly because they have the Smithsonian seal of approval on their resume. They can show off their work, which is far in advance of their years, one would think. And they worked in team efforts. So it's a good deal for high school students. It's a good deal for college, for students who've finished their undergraduate degree and trying to find a direction in life, a career, or maybe they know what they want to do and not quite sure how to get there. The professional training they get through SEAL is just a great deal. And most of our guys, all of my guests of the younger crowd, have all gone on to graduate school, earned master's degrees. We have 2 of them finishing their doctorates. So anyway, the system we have at SEAL opens up a lot of opportunities for folks. So what do scientists do? You know, a lot of folks help out digging and screening, and to me, that's being a technician. And there's nothing wrong with that. I mean, it's important. Like I said, we all are technicians from time to time. But scientists do more than that. Science is driven by questions. What do we want to know? And once we develop those questions, non-trivial questions, questions that have a chance of being answered, like what's the meaning of the universe? You know, that's not a scientific question. It's not answerable. It's not a well-formed question. So the next step is to develop methods that are appropriate for answering those questions and then implementing those methods. And the methods have to do with collecting data, and they have to do with analyzing data. We then interpret the results of the analyses and then share those findings through publications, technical reports, conference presentations, public presentations. That's what scientists do. And at SEAL, we give people the opportunity to do that, to take it from soup to nuts, to identify problems and to report on the results. Now, we've got a couple of folks, you know, there's Ray Sarnacki here. He's certainly up to his hips in one of these projects right now, as are a couple of other folks. So anyway, I'm just, the rest of the evening, I got 4 case studies I want to go through. Some are a little longer than others, but none of them are terribly long. I'm going to start off with the study of erosion and sedimentation done by Sarah Grady, who, when she joined us in 2012, was more or less fresh out of undergraduate school. She was working in a local restaurant, a restaurant that one of our CERC staffers used to go to all the time. And that staffer told Sarah about this new archaeology program, and she was interested in that. By the time she was through with us, she had gotten her master's, worked with me for, I think, 7 years, left me to marry some opera singer and move to Paris. We won't talk about that. But this is the work that mostly she had done. Now, again, as part of a team effort, but she headed it up. This is at CERC. We have 2,650 contiguous, mostly contiguous acres around the Western Road rivers. And at the entrance to campus is this house, the Selman House, consisting of the 1735 original building, half of which was removed in 1841 to create this larger part of the house. The photograph dates to probably late 1970s, early 80s. Well, the road into campus is out here, up near the top of the screen. And an automobile driveway, a fairly recent innovation, came up this way. Well, right in this area here, we shovel tested. We put shovel test bits in all over this house lot, every 7 meters or 21 feet, digging a little round hole, maybe 1.5 feet in diameter, foot or so deep, collecting artifacts, describing soils, backfilling the holes. Well, pretty early on in this area here, right near the road, we found remains of a building. And that's what sparked interest. So we know people lived at this, we know 3 households, 3 families lived here over the course of close to 300 years. And they included Selman family and the Kirkpatrick Howitts. And they're the ones responsible for really creating what is truly an artificial landscape. So right over here, we found remains of the foundation. And here it is. This is like in 2012 that we first hit this, soon after starting the project. And this is a drawing of some brickwork we found. Here's a photograph of it. And a couple of years later, we expanded our excavation and found all this on the left-hand side, fieldstone foundation. Now we discovered that the brick that we originally encountered was actually an addition to an existing building. Here's a view of our most extensive excavation. The brick foundation is over here. The stone portion is over here. This large brick pavement here is almost certainly a large hearth, fireplace in which people cooked. Now, a large part of the building had been destroyed. The driveway I mentioned earlier cut right through it over here. And in fact, this Wednesday, we're going to be digging on the other side of that driveway and see if we can't find more of the summer kitchen. But this is a tip of summer kitchens were common with wealthier plantations because during the summer you cook there instead of in the house. So you keep the heat out of the house and you also reduce the chances of fire. And at the same time, that summer kitchen would be a place where you would house some of your servants and or slaves. But what I draw your attention to is look at the sod here. Look at the excavation. There's no soil development here. We found that brick right under the sod. Not only that, but when we examined the brick over here, you can see it's dug out a little bit. There are only 3 courses of brick there. You can't build a house on 3 courses of brick. What happened? That brick had to come up a lot higher, and so did the soil. Where did all that soil go? There's been a lot of soil loss. So where did it go? And how, and when did it happen? What are the mechanisms? We just, across the road, you see a fence here. Down this hill, it drops a good 20 feet or so to the edge of this woods and a spring-fed creek. Down there, we dug an excavation unit to see if we could capture some of those sediments that used to be up here in front of the house. And that's what we've got. There's Sarah there, smiling away as she always does, digging this hole that went down about a total of 4 feet. And this drawing here shows the different lenses. It shows you, charcoal that we found through many of these lenses. What's all that charcoal doing in there? And also in many of these lenses, little bits of artifacts, ceramics and glass that were exactly like the kinds we found on top of the summer kitchen. So it's pretty clear what we have is a series of events where soils are washing from the front of the Selman house down the hill, and they're deposited at this point. So what Sarah did was kind of an interesting little experiment. We've got 4 units up over here, and just a little bit downhill, 3 units, and then 1 unit way down here. And what she did was she looked at the ceramic sherds that we recovered from each group. And I don't know if I can move this thing out of the way. But anyway, we've got different ceramic types. Here's the units 1, 5, 6, and 8. So these are the upper ones. Units 2, 3, and 4, just a little bit downhill, and 11's at the base of the hill. And these numbers are just the average weight in grams of each of the sherds recovered from those units. And it's not a perfect correlation. You see it drops from 1.33 to 0.4 here, then it jumps up a little bit to 0.7 downhill. But generally, and especially the average weight all told, the upper units, the average weight was a little over 2.5 grams per sherd. Slightly downhill, a little under 2 grams. At the base of the hill, just a little over 0.5 gram. And that's what we call a fall-off curve. And what that means is that as we go downhill, the larger sherds drop out of stormwater, out of moving sediments sooner as the soil is going downhill. As it goes downhill, it gets slower and slower. There's less energy, so the larger particles drop out. Until you get down to the very bottom of the hill where only the smallest bits are in there. It's a basic principle in geology. We see it with silts, sands, and gravels. The siltier material winds up downhill. The heavier material, the gravel, and the sand drop out of the flow sooner. So that's what was going on with these ceramics. So she demonstrated pretty well that that's what's going on. The stuff is soil's washing from the front of the house and down the hill. The other part of this that we haven't looked at really yet is that here's that driveway and the summer kitchen's just to the left. That driveway was not dug that way. That driveway is the way it is because of erosion. Until somebody had the foresight, or hindsight, I guess, to pour some concrete to help slow down the erosion. The difference from the top of the slope to the top of the driveway is about 5 feet. That's how much sediment has been lost. That too has washed downhill. Anyway, so that's just one study looking at how those people who lived in that house affected the local environment. I mean, they built a house, they had this yard around it, and whatever activities they were involved in, which might have included not only the use of that summer kitchen, but by the time it was demolished, say 1840s, 1850, just the fact of raising the building, destroying it, may have increased erosion as well. And it turns out we were out in the field just this past Saturday. Sophia, who's on this call, she and I were digging some shovel test pits next to a cemetery in the woods just north of the Selman house. And we're basically confirming the same sort of process where a site, a colonial period site, has effectively been lost through erosion. Second case study is a fairly brief one. This is done by George Reisling, and it was a project in St. Mary's County in Leonardtown, near Leonardtown, at St. Francis Xavier Church, which is in Newtown, just down the road from Leonardtown. It was a Jesuit manor. They had a chapel there they established in 1664 along with a cemetery. And to our surprise, they also had a house there for the Jesuits that we found. And let me show you. So here's the church, but this is the new church on the left. This is around 1735 and was built after restrictions on Catholics were lifted in the early 18th century. Now, what George is doing here is he's working on part of the site that's about a half a mile up the road, and that's where the old St. Francis was, dating to about 1664. Here's the cemetery here. We originally mapped it at the request of the then pastor, Father Brian Sanderfoot. And you could see a lot of the gravestones here, little white bits. And even a couple over here, a couple over down at the south end. After we mapped it, we did some shovel testing, again, at Father Sanderfoot's request. And we found what appears to be a late 18th, early 19th century domestic site up here, a dwelling. We found some brick, we found some ceramics relative to that period. But what Father Sanderford wanted as part of the 350th anniversary of St. Francis, he wanted to know where the chapel was. Well, we dug some shovel test pits down here as well, and a couple of them produced really, literally, I think just 2 artifacts that might be from the 17th century, that might be from the 1660s. So we engaged in a more extensive excavation. Here's a couple of these 5-foot by 5-foot squares. Again, not a lot of soil here, but you can see remains of a pavement made mostly of gravel, but also some oyster shell and some artifacts through here. But these, where you see less of that, these are graves. Somebody dug graves through that pavement and backfilled it. So a lot of the material you see on the surface on the right is now incorporated into the grave shaft. And this is not an up-to-date map because I haven't drawn in everything that we found yet, but at least on this version. But all these are grave shafts. Every 5-foot by 5-foot square we excavated there hit at least 1 grave shaft, and sometimes 3, 4, even 5. What do we got? Actually, maybe in these units down here, 1, 2, 3, and 4, there may be as many as 6 grave shafts there. So in the process, we found what we think is the chapel and the priest house just south of it. During the course of this work, we were going to have a journalist come out one day and talk to us about what we were finding. Well, the day before the journalist came out, this little beauty came out of the screen. One of our volunteers found this, apparently a swastika. And it's like, oh my God, Nazis. It's like Indiana Jones. We got Nazis here. And it was troubling because we were going to have a journalist come the next day, and you can't hide something like this. When you find something like this, you need to be open and honest about it. It's an unusual find. But it was at risk of really capturing the attention of the whole site. You know, we'd end up with a story that was more about the swastika than about the chapel and the Jesuits' house. Well, George cleaned it up, and 2 things became pretty obvious. 1, it's a fairly thin copper alloy metal, and 2, it's got this vine-like design going through it. Well, this isn't the kind of thing your average SS stormtrooper will be wearing on a uniform. It's only about a 1-inch square, so it's in the size range, but it's just, this is not part of a World War II German uniform or anything like that. But George, through a little bit of research, fairly quickly found that it's not a swastika, it's what's called a Fylfot, F-Y-L-F-O-T. And the swastika design is almost universal. It's kind of a symbol for the sun, if you will. And it was very common amongst Renaissance Catholics in England. And he found this represented on sarcophagi, especially in which bishops and the like were buried in. But also the symbol in this form would have been sewn onto priestly garbs, vestments. It might find itself on a Bible, or decorating a box in which a Bible or other religious books were kept. And in fact, it's the only artifact out of all the artifacts we found on the site, and there are many, it's the only one that actually has direct religious connections. Everything else you could find, just as easily find on any house site of that period in southern Maryland. So George researched it and actually published an article in Maryland Archaeology on the Fylfot. And so in so doing has introduced us all to this new kind of, this artifact with which we are not familiar, and providing a source in which we could do additional research. Case study number 3 is kind of interesting because it's about looking at oyster shells, of which we find in huge numbers on a lot of sites near the coast. Native American, going back 3,000 years, to sites dating from the 1950s. One of our colleagues at the National Museum of Natural History, Torben Rick, with others, has analyzed oyster shells from up and down the Chesapeake Bay, with the testing the hypothesis that earlier oyster shells from earlier sites would tend to be larger than those on later sites. And they attributed that reduction in size over the centuries to overexploitation by humans. So we're in a position, we've got all these sites, and unlike Tory Rick's work, which he's sampling places all over the bay, we were able to assemble a nice sample of oyster shells from a bunch of sites dating over several centuries, right around a single waterway, the Road River. So we don't have all those other variables to deal with, different water salinity and stuff like that. So we have a better sample and said, okay, let's see if we can't replicate what Tory and his team had done. And so the team was pretty much led by Katie Cannon over here, who at the time was, I think, 16, maybe turning 17. And her staff, if you will, consisted of Leo Plourde, who's a retired elementary school principal, and Jim Breedlove, who's a retired program manager from that agency, the name of which will not be spoken. And so what they did was they, using a published guide, took a variety of measurements, much like Tory had done with his samples. So for instance, they'd look at the height of the oyster shell and plot that in terms of millimeters along the left-hand side. And each of these little dashes essentially is the oyster shell. We have samples of 60 lower valves, the left valves, that's where all the meat is, from 2 sites. One, the blue being Shaw's Folly, which dates from the 1660s to 1680s, and so should have larger shells. And the other from Conti's Wharf, a slave site, not too far, within a quarter of a mile, dating to roughly 1780s, 1790s, into the early 1800s. And you can see plotting, just plotting these shells, you can see that the distributions are pretty similar. I mean, there's a little bit difference with Shaw's Folly. There's at least in a small subset of the samples, the Shaw's Folly shells tend to be a little bit larger. Okay, well enough. What they did that was particularly innovative is they said, well, let's look at the volume. Instead of, the size, I mean, you don't eat an oyster based on its height. It's what's inside the oyster that you actually eat. So folks said, okay, well, let's look at the volume. How much meat did these oysters hold? And so what they did is a very simple technique is they filled each oyster shell with sand. This is the kind of sand you can buy in a hardware store for sandboxes. They'd fill the shell with sand, they'd strike off the excess using a pencil, then they would empty the rest of the sand that's still in the shell onto a scale and weigh it. And so the weight of the sand became a proxy for the volume of the oyster. Works wonderfully. And to make sure there wasn't a lot of error, they took one shell and measured it 30 different times just to measure, what is the error? Because this is not, if you use sand grains, you're not going to get the same number of sand grains every time you do this. So what's the kind of error, and is it a tolerable error? And they found, yes, it's actually a fairly small error. And so they came up with a graph like this. And again, Shaw's Folly and Conti's Wharf. But notice, there's a much bigger difference here now. And that difference is really the last quarter of the sample. The largest 15 out of 60 shells is where you see the biggest difference in volume between Shaw's Folly and Conti's Wharf. The earlier site producing shells with much larger volume, at least at the large end of the spectrum, than the later site. Of course, the rest of the samples are pretty similar. Now, this does not disconfirm what Tory Rick and his team said, but it suggests that the relationship is a lot more complex than that and requires a lot more analysis. And we will plague here. We were starting to do this with a whole bunch of different assemblages dated from different dates to see, if we see a significant trend from the 1650s and 60s to the 1950s. Katie, by the way, I guess she's probably finishing now at Duke University. She went from high school to Duke University by way of Smithsonian. The last case study is kind of an odd one. This is started by Mike Eibel, who's not actually with us anymore. His work life has kept him busy doing other things. Hopefully he'll rejoin us soon. And after he started, Barbara Israel came in and started doing some related work that I'm not going to talk about. But the two of these folks really were involved in the copper mining in Maryland. It came about by a fluke. I was going to volunteer. I did volunteer with a small group of people to do an archaeological survey of a small property up in western Baltimore or eastern Carroll County. And there was supposed to be an aboriginal lithic quarry nearby. What does that mean? It means a place where there are large pebbles of quartzite that Native Americans were collecting and using to make stone tools, probably on the order of 2,000 to 4,000 years ago. Mike wanted to come and play, but he couldn't. He had some other commitment. But that's clearly where we had a misunderstanding, because he said, well, I'll go up in that area later and walk around myself. And so I think it was as early as the following Wednesday. We're doing the work over the weekend. The following Wednesday, he comes back to me and talks about these huge pits and stone foundations. And I'm looking at him going, what the hell are you talking about? That's not a Native American lithic quarry. And what he found was a place called Mineral Hill. This is up Maryland 32, north of Eldersburg. Just you cross over Liberty Reservoir, and it's just off there to the east of 32. There's a place you can pull off your car, and then you take this long winding trail, very steep, to the quarry site, to the mining site. And even in this photograph, you can see this area in the center. That's actually the tailings pile. That's the waste rubble from the copper mining. Yeah, before Mike started talking about this, I never even heard about copper mining in Maryland, so I learned something just from the get-go there. Huh. There we go. So that's the back of Mike anyway, carrying, looks like the tripod. This is land, it's part of the reservoir, Baltimore City Reservoir. They own it. And we can go in and map as much as we want. We can do all the drawings, take all the pictures we want. That's fine. It's actually sort of a park area. It's open to the public. But we're not allowed to dig or collect without permission. And we, at this point, hadn't asked for that permission. We weren't ready to do that. And again, of course, the plague hit. We would like to get back there and do some archaeology. I've talked to the city's archaeologist about it, and she's in favor of it. But at any rate, that's one of the features to map. And in this photograph, you can see these big holes with trees growing out of them. Those are all pits, mining pits, from which copper was mined. And we have evidence, archival evidence of the mining beginning as early as 1742 and going on in the 1760s. We know that the mine was periodically closed and reopened as late as the 20th century. There was a couple of years when it was open. In more recent years, the city of Baltimore bulldozed part of it, unfortunately. But there's still a lot of work that can be done there. So we did our mapping. There's a rather blurry picture. There's Mike holding our pole with a prism. I'm operating a total station. We're doing a map, a topographic map. This hole is deceiving. It's actually deep enough where we thought, let's run a rope off a tree so Mike can climb out again, just in case, because it was pretty deep. And yes, indeed, there are stone walls present. There's some sort of building, a bulkhead entranceway, probably into a cellar beneath that building. Here again is the back of Mike inside of a building. So you could see here's a wall here. There's a wall here covered in vines, and right behind him. On the surface, we could see copper ore. In this stone, you could see the greenish color of the copper. This is what they were after. And there are some artifacts, not many. There's some sort of steel wheel, probably for a pulley wheel that a leather belt would be run over. What kind of machinery they are operating, what this might have belonged to, we do not know. But you can see our folding rule here. It's all folded up, but that's roughly 6 inches. Gives you an idea. The diameter of this thing must have been about 2 feet. We use Lidar, and for those of you who've sat in on these talks in the past several months, you've seen me bring these up before. This is essentially a radar image from, I don't know what altitude, but using energy along the electromagnetic spectrum fired down towards Earth, and then measuring the response, the speed and strength of reflection. And it works in such a way as you can actually remove the forest, the foliage. You can essentially look through it by removing that signal. And you could see, it looks like somebody's got a real skin problem here. It's very rough, but these are all quarry pits and structures. On the right is the topographic map that Mike and I put together 3 or 4 days worth of field work. Pretty strenuous too. I mean, Mike's just a few years younger than I am, and he managed to go up and down these hills pretty well. I confess to doing a little huffing and puffing. But you could see each of these reddish brown circles and rectangles, oblong shapes. These are quarry pits that we measured in. The black polygons, those are the buildings. Now, when were those buildings built? What were they used for? The only way we're going to figure that out is to do some archaeology. Not grand scale archaeology, just some minimal excavation, test pits to recover some artifacts that might say something about the function to which those buildings were put, and also, with recovery of certain kinds of artifacts, figure out what the site dates, what those buildings date to. Remember, it was used on and off for a period of about 200 years, but it certainly was in use before the American Revolution. So this is a site we want to go back to, do some testing. Barbara Israel has found other sites in western Baltimore, copper mining sites. A lot of them are not in as good a condition because of development, but they're out there and they're worth studying. So our citizen science team will certainly be taking up this again soon. Those are just 4 case studies. I got 19 listed here, but this list dates to 2019, put together soon before the plague hit. And we've actually added a few projects since. But some of these have come to fruition. For instance, although it's dated 2018, this special issue of the journal Northeast Historical Archaeology, which is a pretty important regional journal in archaeology, actually didn't come out at the beginning of this year. And the initial paper is by Barney Zuckerman. She's a professor up at the University of Maryland. All the others are by our folks, Sierra Bayek on shell button making, Kathleen Clifford looking at 18th century plantation landscapes, Sarah Janesco looking at late 19th century Southern Maryland farms, and Sarah Grady looking again at the erosion sedimentation at Selman House, and then Jocelyn Lee looking at the port town of Port Tobacco in Charles County and looking at the dietary remains that we recovered there over the years. Sierra has finished her master's in Latin American Studies at UCLA. Kathleen Clifford is finishing her doctoral dissertation at University of Glasgow. Sarah Janesco finished her master's at University of Maryland and helps administer the veterans program in Alexandria, where they work with archaeological collections. The aforementioned Sarah Grady got her master's from University of Maryland and then absconded to Paris for no good reason. And Jocelyn Lee, she should be finishing her master's at the University of Massachusetts, Boston, I think. I don't know what her plans are after that. Oh, and we have an Owen down here too, I didn't see. Valerie Hall, who is working on her doctorate at University of Maryland. She looked at the bones, the fossil remains we've got from our excavations at Cirque. So going back to that list, we've checked off a few. However, let me point out that the shell button making project continues. We're still collecting data. There's still a lot to do there, even though there is a publication. Same thing with the plantation layout and meat provisioning on slave sites, meat provisioning at Port Tobacco. The late 19th century farming practices, that's what Ray and I are working on with a couple of other folks, Tim and Pat. So these projects continue. Each generation, if you will, builds upon. And we've added a few more projects since. So anyway, I've come up with a list of folks, past and present, who are part of the citizen science team. I'm sure I've missed some folks, but you will notice at the very end of the rightmost column, there is space for your name. So by all means, feel free to join us. Things will get better. We will open up CERC more. We do have folks on campus now. However, certificate of vaccination is mandatory. You must have that. But things will start opening up eventually, and we'll get back to doing some large scale work on lots of different projects. So I hope you can join us. And I'll take any questions you might have as soon as I get rid of my stop share here. Anything else? All right, there being nothing else. I have 2 more talks in the series, October and November. I don't remember what they're about, but I got them. So I hope you will join us and spread the word too. Okay.